On.
Are we on? Okay, hey guys, this is Dave Shopius, and my cameraman is Jeff, my robot Rowdy, cut it. Hey everybody, this is Dave Shopius. This is the third, what I think is the third installment of this robot rebuild that I'm doing here. A quick history, a guy sent this robot to me from up north. We're down here in Florida right now. If you haven't seen my other videos, I showed them. Hey guys, this is Dave Shopius. This is what I think is the third installment of this robot rebuild. Quick history, a big fan of Lost in Space who bought this robot. Had it in pieces at his house up north. We're down here in Florida right now, and he asked me to put it together for him because I have some experience in this kind of stuff. So when I got it, it was in pieces, and for these past 4 or 5 months I've been slowly putting it together, mobilizing it, automating it. It's computer controlled right now, and RC controlled for the treads, and I'd like to kind of show you a little bit of what I have. Right now, I mentioned it was computer controlled for part of the automations. What I've done so far, just right now, just the waste. I also have a mobile app that you can walk around and use. Basically, it's very basic. Basically, it's very basic right now. So, what we're going to do here is just show him off a little bit, how he moves around right now, how I can automate him and move him with the mobile app. I'm not going to show you the computer app until another video, but we'll take him down the hall, move him around, roll him around. He'll be moving as he's going in kind of a personality generated loop. So. But basically right now, what you haven't seen is the waist, and with the mobile app I can get him to like move to the left, move to the right, move him back to the left, or not. Everything always screws. There you go. We'll center him up right now. He goes to the center. He talks right now. Right now, he's talking through the Easy Bee, which is I'm using the Easy Robots platform, which is all Wi-Fi controlled. So right now, it's going from my phone through my home's Wi-Fi system and going right to the Easy Bee. And there's a little speaker in that guy. I am actually going to upgrade that to a big full-size speaker so it'll sound like a full-throated voice. And these voice clips are all the actual, I have hundreds of them, but right now I think I only have 5 or 6 in there. But they're the actual voice clips from the voice actor from the robot, Dick Trufeld. So right now he'll say a few things. I don't know if you heard that or not. Oh, that was my fault.
Danger.
Okay.
I know. Let us watch an episode or two of Lost in Space.
And for you Star Trek fans,
Live long and prosper. All my circuits are functioning perfectly.
so that's just a little demonstration what he can talk like. He moves. You saw that. I got a few other animations in here. Basically, I can put hundreds of scripts in here if I want and make him do all sorts of different things. He moves at different, he spins at different speeds. These are just quick, rough, basic scripts I wrote for this, just to kind of show him off. He does a quick waist turn. Or he animated kind of a loop where he goes and pauses at different places and waits for a little bit and goes to different spots, and we'll do stuff like that. You'll notice a little bit of a jerk in there once in a while. That's basically because it's just an empty shell. It needs a little bit of weight. So we'll take them apart a little bit later and show you some of the mechanics I've put into them. So I'm going to let him run on this loop right now. And put this in my pocket, hopefully. And then I will grab the RC unit. This is how he moves mobilely. This is the way I have it set up right now. I'm not sure if I can get him to work on this this mobile app or not with the tread sections. So hold your breath. Oh, there he goes. He's working. You can see him spinning. He's very mobile, very precise, very quick. I got to slow him down a little bit. He's actually too fast. If you notice on the back, you can see, we showed him one of my other videos, we have signatures from cast members. And for some reason he stopped spinning. He wasn't supposed to stop. Maybe it's because I shut my mobile phone down. Anyway, these are like Marta Kristen, that's Judy Robinson. This is Mark Goddard, Don West. I think this is Bob May's daughter or wife. But Bob is no longer with us. There he goes again. So she signed that back in 2015. And here's Billy Mooney. You guys know who that is. So anyway, I don't know why he stopped moving like that before. I'm talking about the animation. But let's take him down the hall. Let's see just how mobile he is. You don't want him to hit nothing. Oop, I think I got him too close. Am I hitting something over there? I don't think so. I think I'm okay. Here he comes. Yeah, I just found out that he's not moving when he's rolling. So I don't know why he stopped doing that. Maybe he's got something to do with the... Oh, we just lost the power. Okay, well, here he is. We got some bugs to work out. I just lost the connection to the Easy B in there, I heard it. So let's see what's going on here really quick. Okay, you heard that beep? I reconnected. So you should be able to run the initiations. I wonder if he'll move now. Yep, there he goes. He's going again. Right now he's going through an initiation where he's rehoming because there's an encoder on the motor that turns the waste and it's got to know where it's at. So I'm restarting the process here. And I'm not sure why it dropped off. Could be a power issue. We'll find out. So now he's back on. Okay. I'm going to set this right here for now. Maybe I'll give it to my buddy Jeff to hang on to. Can you hang on to that? Okay. Okay, we're going to take him back in the bedroom now. And hopefully he won't disconnect again. It's easier to control him from the back because the controls are all right, they're not backwards. Goodbye, B9. They used to call him Blinky. Whoops. His creator, Bob Kinishida, the guy who designed this robot, called him Blinky because of all the blinking lights. Don't want to bump into the walls with him. He's kind of big. Whoops. See what I mean? Whoops. I'm gonna take my robot driver's license away. Now he's on the pinball machine. Okay, we're gonna cut right there and solve this problem. Okay, we saved the day. We got the robot into the World Robot Lab here. He's still running. I don't know why he disconnected before. So one thing I want to show you. I'm going to stop him and center him up. It's good enough. So again, there's some bugs. But one of the cool features that I adapted into this robot. Again, the electrical system's not my design, it's by Bob Ross. And he has this on his robots, and it's really nice. I zoom down here, Jeff. You've got a little, see this plate right here? This is a battery monitor. This guy's powered by two 35 amp hour batteries, deep cell, I believe, lead battery, lead acid. So you push a button and it tells you right now what percentage of the batteries are at. 77%. You see a gauge right here, and this is how many volts that the system's got going through it, 12.5. And after a minute, it'll shut off by itself, so it's not on all the time, or you can shut it off yourself. Boom. A couple of other things. This is the on-off switch. It's a 3-position switch. Center is off. Down is you plug it in through the wall right here, and there's a converter inside of here that converts the AC from your wall to the 12 volts that this guy requires. So, and this is your charging plug. So I showed all that on prior video. So if you want more information, go back and look at my stuff. So let me. What we're going to do is I'm going to turn them around now. And we'll shut down for a second, and we'll come back, and I'm going to take everything apart, and I'm not showing you. If you want to see how this is done, you can look on my other videos. We're not going to bore you with that right now. And we'll see how some of the inside of this guy looks, some of the stuff I've upgraded since the last time I shot a video. Okay, we'll be right back. More to come. Okay, we're back for a few minutes here. Before I take them apart, I just want to show you some of the problems I'm having with this certain torso right here. It's got some inherent problems with it, and I think it caused a lot of irritation for the guy who had this before me. You can see, I hope you can see this, the bottom edge, the bottom of this whole guy is warped. I had to put washers in there temporarily just to get him to turn. You see how close the tolerance is in the front and how big of a gap it is here, and then she squats back to almost nothing back there. I'm going to have to figure out a way to flatten that out. I'm not too sure how to do that yet. I've got a couple ideas, but if it's clamped down right now with those, you see those thumb screws in there, that's how he's going to be retained to the base. And it's a pretty nice little system, but you can see the inside. Also, there's the inside of the armhole. That we're going to talk about that in a minute. So keep that in mind. So if all those thumb screws are tightened down, it warps the Lazy Susan down there, and it won't it won't turn. It finds all sorts of places to hang up on and snag on. So another problem we have is these armholes. If you can see how big the holes are, they're not supposed to be that big. Let me show you a. This is the arm that I got from Wilhoff. It's just beautiful. It's silicone rubber. It'll last 100 years. There's a flange here on the end that's supposed to grab the inside of the armhole, but they've got that thing cut out so huge that you can see it's just not even close to being correct. So I'm going to have to find a way to fill the plate over this hole cut a new hole, and so it's the proper size for this. Another small issue that I don't think is going to be an issue at all is, I don't know if you can see it right here, right there, there's a crack in the torso. Somebody in the past abused this thing or dropped it. It's not really hurting the integrity of the structure. It's cracked through just on this rib right here. Maybe I need to find a way to reinforce that a little bit. But the problem is there's going to be a cover that slides back and forth, a vent cover. So it's going to have to be something inobtrusive and flat. So those are basically the problems I'm having right now that I have to overcome with this torso. So I'm going to stop again, change. What?
The plug, your power.
Oh,
plug
Jeff's making all these little comments on the side, and he's going nuts. And that's right. Okay, that there is one more problem. Thank you, Jeff. What would I do without you, man? Yeah, the other thing is that this is where the power pack goes in, and you can see those holes are huge. I don't have the power pack handy right now, but I think I'm going to have to somehow close up those holes and re-drill them. So that is another problem. We'll see. We'll see how that works. So anyway, anything else, Jeff?
No, that's good, Dave.
Okay, thanks. I'm going to shut off right now, change the battery, and give the camera duties back to my buddy. Okay, guys, we're back. Welcome back. I've got the legs off now, and the torso off, and all you're seeing now is just the skeleton and his innards. I just want to show you what I've done since our last video. I'm giving Jeffrey a break. He's earned it. The guy just works his butt off around here. So I'm going to take the camera for a few minutes here and give it back to him in a minute or two. So what I've done since our last video basically is just worked on the waist section here. The animation for the waist section and the automation part with the computer support for it. So as far as the electrical, it's actually, everything's off right now. So it's in freewheel mode. So you can see what I have here is looking at the motor here. I got a little motor. I can't remember. It's like an MR200 from Global. I can look that up and put it in the description later. But it's a nice little motor, and it has a encoder on the bottom of it that's attached to the motor shaft. So that thing is a high precision, very nice little optical encoder. And just a quick note here, you'll see this skin on here. That's a soundproofing that I put on there, kind of a Dynomat, I think it's called, just to kind of knock some of the sound down, which is a nice feature. I don't like noisy robots. What you have here is basically just a little lock ties that I have, lock wraps that I have around it to keep the motor from bouncing out of the gears. I'll talk about that in a minute. So it's just basically wraps around the motor and goes around a little loop here and keeps it from bouncing, because if you notice I have this mounted on a hinge, a springed hinge. And what that does, it allows it to move a little bit and take care of some of the odd parts of the motor if everything's not lining up just right. So it works pretty good. So I've had that on my robot for years back in the other room. So anyway, that's basically what that is. And then we have a nice gear set here that I got from one of the vendors from the B9 Builders Club, B9 Robot Builders Club, and it's very nice. The guy's name is John. And what we have here is limit switches. So when this bolt that I have mounted in here goes around all the way, it'll hit that limit switch, and the computer knows exactly where the motor is, and everything's at as far as speed. So, and position. I'm sorry, position. And that encoder sends all the information down to the motor controllers and the computer controller down there. We'll get into that in a minute. So basically, that's about it. It's pretty simple. You got your motor, got your limit switches here, got your bolt to hit the limit switch on both sides, and it's just, like I said, it's just pretty simple design. So what I want to do now is I will hand this over to Jeffrey, and I will turn on the robot. Here you go, Jeff. And what you'll hear, step back here, Jeff, and take a look. This is the EasyBee, and it's made by Easy Robot Incorporated. And it's just a little wonderful, easy robot platform for anybody like me or you that don't know a whole lot about encoding scripts for computer language. It's just very great. But anyway, what it's going to do is I'm going to turn on the robot. You'll hear a chime in a woman's voice saying it's connected to the network. What it's doing then is it's hooking into my home network over Wi-Fi. I think in the end I'm going to mount a little router in this guy, so it'll hook into its own router. It'll have its own little network, and it won't have to go from the computer, through all that jazz. So the other part of it is over here on this laptop. I have Easy Builder running, and this is the control system that goes through it. This is also hooked up to my Wi-Fi, and it'll send commands over to the EasyBee. And I have that well documented in other videos of mine too. So if you want to go back in my 50 other videos and find some of that stuff, you can. But we're not going to talk a lot about that today. So here we go. We're going to turn this guy on. You'll hear the woman voice come on.
I have successfully connected to your network.
Okay, we're hooked up to the network. Now I'm ready to come over to the program, and I have to turn on and connect the program. Jeff, you want to come over here and take a look at this? And what I have is an initiation script right here. That's I'm not going to go into it deep. I'm just going to show you really quick. Inside, it's just a set of commands that initiates the UART port on the EasyBee, and it starts a homing program in the Kangaroo that's hooked up to the motor controller, the Sabertooth motor controller, and then just a little animation I have programmed in there to on another script, another part of the program, to bring it back to center, kind of give it a nice look. So let me back out of this. I'll hit this start button, and you'll hear you'll see this thing say connect, and hear a beep, and then we can swing back around and see the animation start. Okay, there it goes. Okay. It doesn't have to hit the other limit switch because it already knows where it's at. It just goes, now it's in that animation script where it's coming right back to the front and center. And that's basically it. Now it's centered. Don't let these arrows deceive you. This bolt pattern is different. This is actually, once it's actually lined up with the front of the robot, not the torso, like you saw before. Now I'm going to just run a couple of these quick animation scripts that I have here. I have like a loop and a little animation and a fast and slow twist, and these all can be triggered by voice recognition too, or however, or on that mobile app you saw before. They're all tied together. So, okay, Jeff, why don't you just take a look at, and I'll show you what I'm doing here. Hit the start button on this first one. This is just a fast back and forth animation. And then maybe another slower one, so I can get different speeds, different positions, whatever I want to program in there. You can see that's a lot slower. And here's a faster one. Again, these are just basic, quick programs that I wrote up. I can write one with this easy script. I can write one of these scripts in like 30 seconds. It's just amazing. And this is a loop, so I'm going to stop it. Then I have another script to bring it back to center. Just amazingly easy. I'm going to start the a waste animation where it just goes on a loop back and forth. And if you zoom in here, Jeff, you can kind of see, watch the, see how that kind of wobbles back and forth, the motor is making up for the differences, that spring latch is making up for the differences in where that thing's riding. So, and the problem is, if you could put a lot of weight on this guy and get it really fast, it'll jump these teeth and screw up what the encoder is reading. I won't know where it's at, and it sounds terrible. So that's why this I have this little rat lock tie back in here, this Ziploc tie that keeps from jumping those teeth. So you can see I can pull that back and forth. See, this is basically it. Okay, guys. Well, I'm going to now stop this, take this off, and we'll do a really quick tour of what's down below, and then that'll be it. Thanks for watching this, folks, so far. Okay, we're back. We're going to talk about a little bit what I have in here. This is my control panel, basically, where all my stuff is mounted, electrical stuff, like electrical panel, you could call it. You've seen a lot of this stuff in my other video that I had before this one. The big addition now that I'd like to show you is the EZB. Again, this is by Easy Robot Incorporated. It's kind of like a receiver unit that you saw. It receives the Wi-Fi signal from my network that's generated from the computer on the Easy Builder software you saw before. You can go to their website, easyrobot.com. That's easy/robot or easy-robot.com and read about it if you're interested. Mainly it can power like 28 servos. It's got what is it, 12i capacity. It's got serial ports, 3 serial ports on it. So it's really pretty cool. And this is power. It's sitting inside of the base right now with a 20-volt fuse inside of it, so you can run 20 amp fuse inside. So you can run 20 amps through this thing and deliver whatever voltage you're putting into it out to your servos. So it's I'm not going to get into it, but it's really pretty cool. It connects through Wi-Fi. It's all wired into the regular system right here, and right now it is controlling this Sabertooth. This is a X2X. Let's see. It's a 32 amp Sabertooth. So, and this little board up here is a Kangaroo, and that takes all the commands and input commands from the EZB over here, says it to here, and this Sabertooth is able to position the speed and the position for this little Sabertooth right here. And what this is, it's a resistor that allows only this model of Sabertooth to be hooked up to a power supply. So I can plug this thing into the wall, go send it through a 12 volt power supply, and it will transform it in through this thing, and it won't. This puts out regenerative power, so it won't kick back and blow up the power supply. I think I might have explained that in one of my last videos, if that was a little bit too convoluted. So basically, this works the waste motor right now. What this is the Sabertooth. It's the same Sabertooth as this. It does not have the Kangaroo attached, and this runs the wheels that makes it mobile. And it's hooked up to an RC receiver right now that you saw me have in my hands before. This received the RC signal and runs it right straight into the Sabertooth, and it's just a beautiful system. And the rest of the stuff is just wiring and relays. And I talked about that a little bit in my last. So anyway, guys, I just want to thank you for watching this long video. I hope you enjoyed it. And I will be back with more when we have some more stuff to show you. So have a great day. See you later.